to talk about a problem that I caused. My name is John Belkowitz, and I am the Director of R&D at Intelligent Concrete, where we make concrete do the impossible. Sometimes that's not good. So, what we're talking about today is we're building a concrete countertop. We've got it curing outside. We did an acid bath yesterday. We have a major component missing. We are putting in a glow-in-the-dark concrete section with these optical fibers running through it. So not only will we have, lights underneath showing through these optical fibers, but once we shut off the lights, and it's in the shape of our logo, how cool is that? Once we shut off the lights, then you'll get to see the glow product around where the optical fibers will lit up. So it's a really cool concept. What it requires is a very specialized mix. So I started off with the base, the mix that we use, the glow-in-the-dark grout that we use for our business cards. And let's take a time out. Like, subscribe, share, I don't care. Just do something that gets our information out there, because our job is to save the world with all the concrete in it. And we can only do that with the help of viewers like you. That almost sounded like a PBS thing. Yeah, anyway, so yeah, glow-in-the-dark concrete for you. The piece that I'm trying to make, it has to fit into this cylindrical portion, which is not hard. It's actually going to be free to move. And we can even put it into a humidity chamber, which you're going to see in a second, but it also has to get around those individual fibers. Then it has to be fluid for a very long time to allow for consolidation, but it has to have a setting time to make sure that we're not going to have any bleeding or segregation, because the surface that we inject, or when we place this, it's that top surface that's going to be what our clients are going to see, or what we're going to see when we put this countertop in place. And we really only have one shot, because making that optical fiber thing is pretty darn difficult. Okay, so ding! What problem did I create, and what problem did I run into? So what you're going to see right now is I'm opening up our humidity chamber. We don't normally like using 100% humidity chamber. They're very hard to keep. They have a tendency of running out, so we created our own portable, semi-permanent, I guess is a better way of saying it, humidity chamber, and that's what you're seeing right here. Now, let me take out the samples. So as you can see, there's a beautiful 3 panels that we've made. The first one, which was mix 1, where I created a problem, and I've already addressed this. What did I do? I took our base mix, I pulled out the non-chloride accelerator, and I added the residual amount of water, and I added way too much water. So mix 2, this yellow panel, I took that water out, or a portion of that water, and I also replaced that portion of water that I took out with a small amount of that non-chloride accelerator, because when I took the whole amount of that non-chloride accelerator out, I wasn't getting the gelling or time of set, both initial and final, that I had intended to get with this concept. So that still didn't get past this major problem, and I had to show the second one for you to understand what the problem was in the first one, and that's an excessive amount of air at the surface. And you can see these huge air bubbles that popped up to the surface, and again, that is part and play of the amount of water that I put in combination with a high-range water reducer. We did a video on that. So again, I'm yanking out the water, putting in that non-chloride accelerator, and as you can see, don't have as much bubbles as I have on the white one as I do on the yellow, but I still have a lot of bubbles, and it's not what I really wanted. So the third mix that I did the same thing. I reduced the water, so I increased the NCA content, but on the third mix, I did 2 other things, and Whitney likes to call that the kitchen sink, when I'm really trying to throw all my ideas and going past that one parameter change. And on this third mix, put in a defoaming agent, powder-based, and then I also used a mechanical vibrator. And I don't think, I used our vibratory table, if you will, and I don't think I'll be doing that on the next round. I'm taking the vibratory table out, because once I pull those optical fibers through, I really won't be able to use that vibratory table. I might be able to use the stinger, or what's it called, a palm sander, to get that same vibration, but I really don't want to rely on that. That being said, you can see I'm also going a step further in reducing that bubble count. So I'm going to be doing one more mix where I'm using the defoaming agent, and I'm also using a different glow pigment, which has a tendency to increase the bubble content. And then finally, I'm using a different style of high-range water reducer. I'm still using polycarboxylate based, but it's going to have one less chemical in it that sometimes can cause this excessive bubble content that you see right now. So stay tuned, and hopefully you're learning something from this, and I'm not just wasting my time. Of course I'm not, because you're awesome. Thanks for joining us today. Don't forget to like and subscribe. Did I do the whole shtick in the spiel? I did? Go concrete! Beat asphalt!